Hello guys, My name is Shreyas Limaye, and welcome to my design innovation video. My topic is printed circuit boards. Printed circuit boards have been fairly common in our day-to-day lives. They have been used in computers, medical devices, automotives, etc. So what are these PCBs? PCBs are basically devices which mechanically support and electrically connect all the devices in a circuit with the help of conductive tracks which have been etched upon a non-conductive substance known as a substrate. The PCB is mainly made up of two sides, the track side and the component side. Track side basically consists of conductive tracks made out of mostly copper because of its conductive properties, and these form the circuit which needs to be connected in the device. Uh, the component side consists of all the components like capacitors, transistors, etc. These are fitted onto the PCB with the help of holes drilled into the PCB and are soldered to the circuit below. Basically there are three types of PCBs: the single-sided PCB, double-sided PCB, and multiple-layered PCBs. Single-sided PCBs have the copper layer on one side, and hence they can have the conductive lines on only one of their sides. The double-layered PCBs have copper layers on both of their sides, and they can have conductive tracks on both of the sides, increasing complexity. And the multiple-layered PCBs are basically a lot of double-sided PCBs stacked upon each other, which allows for a lot of complex designs. So what is the manufacturing process of the PCB? So the first step is to design the stencil of the PCB, that is formation of the circuit onto a stencil and selecting the materials for the substrate and the tracks. Second step is printing of the PCB, which is done by uh, placing the stencil on the copper layer of the PCB, which has been treated with the help of a photo reactive material, and UV light is passed on the stencil. The copper reacts to the UV light in the area exposed by the stencil, which leads us to the third step. The third step is getting rid of the unreacted copper. This is done by a special chemical which leaves behind only the copper tracks which we need for our circuit. The fourth step is inspection to check if all the copper has been removed, and the fifth step is laminating, which increases the life of the PCB. Why is the PCB innovative? So here's the answer coming for you. So before the invention of the PCB, we had methods like the wire wrap and point-to-point construction. Isn't it scary just looking at these circuits? And imagine if you had a fault and you had to find a fault in these circuits. Sounds scary, doesn't it? Well, the PCB eliminates almost all of the flaws which have been introduced by wire wrap and point-to-point construction, which is basically connecting the leads of your devices with the help of wires. So here are the advantages of the PCB. So the PCB allows for miniaturized circuits and increasing of the lifespan of your device. Uh, it also allows for easier manufacturing since the stencil and all the processes can be completely automated. With the help of multiple layered PCBs, we can have a high complexity of circuits. The absence of electrical wires also means that there is no electrical noise. Since we can use mass production methods, it's easy to replicate these designs, and we do not need skilled labor to make PCBs. It is easier to find faults because of its organized structure, and it's completely portable since it is robust and can easily handle shocks, since there are no loose wires attached to the leads of your components. So how was the PCB developed? Well, of course, it didn't just pop out of the sky or pop into the head of an inventor that let's make a PCB and he made it. So it has been developed over the years over several prototypes, which you may call. The first prototype or the initial PCB was invented by Paul Eisler for his first radio. As you can see, the component side on the picture in the left, the components have been placed on top of wood, which acts as the non-conductive substrate, and the wires or the conductive tracks have been attached below, which forms a circuit. Of course, this is a very crude structure and it is not very complex, but as you can see on the picture on the right, the development of the PCB over the years has been staggering. So it increased from multiple and double dead PCBs to high density interconnection PCBs to bendable function, which has been achieved by rigid flex, and so on and so forth. So hence we can see that the PCB has developed a lot over the years, and the reason I find this device innovative is because it originated from a simple idea that drawing structures, like drawing circuits, is easy, but making them is really hard. So wouldn't it be better to just print the circuits which we need to make, and converting this idea into an actual device or into an actual design was really commendable, and this is why I find this design really innovative. Time, have a good day. Goodbye.